Hey everybody, I'm super excited because I finally got a way to use Smart Notebook and share my lessons with you guys while we do our distance learning. So I just want to cover the concept of seafloor spreading in a little more detail. So this is just a continuation of the lessons we've been learning really. So let's say, this is the ocean and we had two rafts. So this black raft was raft, let's call it raft A. And then this red raft was raft B. So both rafts, or whatever, rocks or boxes or objects, they're both floating in water. Okay? Therefore, they're both less dense than water. And we spent a lot of time learning about density. So you should hopefully fully understand that concept. Whatever's less dense floats, whatever's more dense sinks. But just by looking at how they're floating, which one would you consider to be more dense than the other? And the answer is A. A would have a greater density. Okay. Let me use a thicker pen because I'll write better. So A has greater density than B. You could tell that because if you look at A greater percentage of it is under the water. While if you look at B, that's the water line, see? A greater percentage of B, look at how much of B is above the water. That means B has a lower density because look at how much of A is below the water. All right? So understanding on how things float is actually a crucial concept, which is part of density in understanding the theory of plate tectonics. So if we take that same analogy of how things float, and now we relate it to an ocean of magma. So let's say we had an ocean of magma, but instead of it being rafts, it's crust that's floating. So this would be the ocean crust. And then this would be the continental crust. So which one's floating at a much higher position? It's obviously the continental crust. This one. Okay? And the ocean crust is not floating as high, which is why they have such a difference in their elevation. The ocean crust is very low, and the continental crust is very high. Okay? Now we're going to add one more thing into the mix. Let's go back to that previous page. Let's say we had, so both of these objects are floating in the ocean. Let's say an ocean current was coming up and then moving to the side, coming up and moving to the side. Well, those two floating blocks are going to move with the currents. So block B is going to go off to the right, and block A is going to go off to the left. So these blocks will actually separate. Okay? So this is really the premise or the major concept behind seafloor spreading. What you have is rising magma here. So the magma comes up and then moves to the side. causing the continents to spread, causing the seafloor to grow. We call this seafloor spreading. So it's the same exact concept, but now with magma. So remember, both these crusts are floating on an ocean of magma. So the magma will come up and then move off to the side. Come up, move off to the side, making this block turn to the left or float to the left, and this one float to the right. So making these things separate. Once again, this is called seafloor spreading. And what will form in the middle is a mid-ocean ridge. Okay? But eventually the separation has to stop because Earth is only so big. So let me draw another picture. So let's say this black slab here is ocean crust. Okay? And this bigger black slab, put myself over here, is the continent. So here you have, I'm going to write OC for ocean crust, and here you have continental crust. And the ocean crust is heading on a straight collision course to the continental crust. So the ocean crust right here is moving to the right. The continental crust is moving to the left. And they're going to collide. Let me draw my ocean here and make it bolder. So here's my water. So the whole ocean crust is under the water. Right, this whole thing is water. This is all ocean. Okay. Part of the continent is under the water, but since most of the continent is thicker than the ocean crust and less dense, most of the continent remains above the water. All right. Which is why we can live on land. Okay. But due to the ocean crust being thinner here and denser, it has sunk into this magma, giving it a lower elevation. All right, now let's draw in the magma. So the ocean crust is going this way. Now the continental crust is coming this way. See, they're heading for each other. And what's going to happen is this ocean crust is going to dive down. Okay? This is what we refer to as subduction. And the ocean, at the point of subduction, look how deep it gets. And that is what we call, let me use a different color. That is what we call the trench. So the trench. So the trench is forming because the ocean crust right here is colliding with the continental crust, and the ocean crust is forced down. The downward motion is called subduction. Sub means to go under. Like if you submerge your body in water, you're going under the water. A submarine will submerge itself into the ocean. Okay? So subduction means to dive under. So this arrow going down, that's subduction. And what it does is it kind of creates a fold or kind of a slit or a thin cut in the ocean, and we call that a trench. And the ocean can get 2 to 3 times deeper. And if you notice, it's right by the continent. And that's what was so weird when this was discovered. The deepest parts of the ocean are actually, if you look here, and they're near the coastline. Okay? So I wanted to just draw this. I hope you understand the drawings. So simply put, the reason why we have subduction has to do with the differences in density. Ocean crust is denser than continental crust. So when they're forced to collide, the denser object will always go under the less dense object. And that's true in everything. If there's two boats that are colliding, the denser boat will go under the less dense boat. So think of the ocean crust as a denser boat, the continental crust as a less dense boat. So the denser boat will dive down. And what do we call that process? That's right. That process is called subduction. And what does it form? It forms a trench. Okay? All right. I hope you understand this, and I hope you like that I was able to finally use Smart Notebook and learning on the fly here. All right. Have a good day.